Hey guys, welcome back. We have now mastered structs for grouping related data. Now get ready for one of Rust's most powerful features, which are enums and pattern matching. While enums in other languages are basic, Rust enums are incredibly powerful. They can store data and enable exhaustive safe pattern matching. So our today's agenda includes the enum fundamentals, which are more than just one constant. Then we will check out the enum variants, which can store data as well, followed by the option and result enums. Then we will check out the pattern matching with the match keyword. After that, we will explore if let and while let syntaxes. And lastly, we will explore the real world enum patterns. This is where the Rust will truly shine. Enums combined with pattern matching will give us compile time safety for handling all possible cases, thus eliminating entire classes of bugs. So let's dive into it. To declare enums, you must proceed like this. Define with the enum keyword a name which can represent your enums. For example, I am declaring here a direction as an enum which will hold a following set of values: north, south, east, and finally west. This is the direction enum. Similarly, you can create another enum named as HTTP status. So it can have the OK status for the 200 status code and a not found status representing a 404 HTTP status code and a server error value which represent the 500 status code. Similarly, you can create another enums for the use cases where you can logically see that something as a collection of multiple values. So to access values from the enum, you must proceed like this. Let direction. Suppose you have to store one of the values from this direction enum into this variable. So proceed like this. Specify the enum name, which is the direction in this case, and specify the value here. Suppose I'm picking north here. So now the direction is holding or say referencing to the north value of the direction enum. Similarly, you can do so for the HTTP status enums as well. HTTP status, okay. Afterwards, you can specify match keyword to check with the some of the provided conditions. Match status, HTTP status, okay. So it must return request successful, otherwise in case of not found, then page not found. Similarly, for the server error as well, internal server error. So this completes the some of the conditions with which we are checking on to the status uh, enums. Afterwards, you can print them. Println direction colon question mark direction. Similarly, for the status messages, status messages message rest c enums.rs. Got an error here for the adding the debug into this. So let me annotate the direction with the derived debug in this case. Okay, it compiled now. Enums.exe direction north and the status messages successful. This is just a basic example of enums in the Rust. For declaring enums with data, you must proceed as follows. Its declaration would be same. Only difference would be at the values end. Page load, then key press, char. This one represents that it will hold a single character. Similarly, a paste named enum, which will be holding a string value, or you can also specify them to hold a struct like value, for example, x I64 and y I64. This is our web event enum, and let's check this. Let events equal to web event page load, then web event key press and a single character into it. Afterwards, the paste and specify a string into it. And lastly, the struct based value click x100 and y100. So this completes the events array having the various web events. Let's check this by printing all these web events in our code base. Let me define a process event function which will take the a single web event and it will check whether it is a page load event or the key press or paste or the click one, and accordingly it will return the corresponding value. And before calling this web process event, we have to iterate over the loop so that we can iterate each of these web events and correspondingly we can get the values printed. Let's compile it now. So got the values, page loaded A, key pressed A, page state text hello, and click that 100. This is the example of enums with data. So as you saw here, this variant of enums can store different data types and amounts of data. Each variant is like a different struct, but they all belong to the same enum type. There are two more variants of enums which are highly powerful. Those are the option enum and result enum. Let me give you an example of it. So the option enum is a variant of enum and it is inbuilt in the Rust. It represents the possibility of a value being present or absent. It is a core part of Rust's approach to handling nullable values and avoiding null pointer exceptions, which are common in other languages. For example, in this code, I have created a some number which is holding the value as 5 along with wrapped over the sum function, and there is a no number variable which is of type option and it is currently holding null. So sum is a variant also that indicates that a value of type T is present or not. By default, the data type of the value which is given to the sum function uh, is by default type referenced to the I32 data type. So some variant of the Rust enum actually provides the assurance to the Rust compiler that the corresponding value is 100% present in the memory, while the option enum actually gives the two possibilities to the Rust compiler, and those two possibilities are that first possibility is that it can be present in the memory or otherwise it might not be existing. Hence, it may throw the null pointer exception. Hence, option enum in that case will gracefully handle that without troubling you to handle it manually. So in our code, uh, if you execute this, you will by default get the for the sum number you will get 5 and for the no number you will get none. However, if you declare two variables x and y where you store the 5 into x, but you declare y as an option which is possibly holding the value 10. And if you try the sum of x plus y, you will get the error because option is responsible with the two possibilities that with the existence of the corresponding value. So for the y, it actually not initializing it with the value 10. However, it is assigning it with the two possibilities that it might be happen that 10 might be existing or it might not be existing. So that's why to handle the discrepancy at the runtime, hence it throws an error at the compile time. So if you actually want to do the sum of x and y, there is the other another alternative way, and that way is that you have to specify a match expression on y and then check with it that whether the value is actually existing or not. If it is existing, this condition will be executed, uh, and whatever value is sum is holding, it will be summed up with the x and it will be stored in the sum variable, which you can later print it or process it for the further computation. Otherwise, if that value is not existing, hence y is actually referencing to the null, uh, null or say undefined case. So in that case, the none condition will execute, uh, under which you can define your error handling condition or the scripts. So with this way, you can sum this scenario, the x and y, when the option enums is attached to one of them. In case of divide by zero conditions as well, you have to proceed similarly. If the denominator is zero, you have to return the none. Otherwise, you have to wrap the numerator divided by denominator in the sum function. Further, with this divide function, we have used it to actually compile it and to see that whether it going to work fine or not. So if the result is actually holding some value, you can directly print it. Otherwise, it have thrown the null error or that there is a possibility that it may be throwing exception. Then you can then it will be automatically processed here. Similarly as well. So this is how the option enums work. And another variant is the result enum. Result enums are also inbuilt enums in the Rust, which is responsible for the proper error handling of the operations which can either succeed or fail. So let me show you with the example here. So for example, I have created here the two functions. First is the read file content to actually read some content from a file and to parse a number from a string. to check that whether it is consisting a valid number or not, and both are returning the result enums. The result enums give two values. One of them is the represents the success part of the operation, which is by actually represented by the OK value, and if it got failed, then it will be represented by the error value, or say ERR. So the result enums actually holds the OK and ERR in their implementations. So let me walk you through the complete code flow. In the main function, first of all, I would be reading a file named as hello.txt. Uh, I have called the read file contents here, which is returning a result enum, and on that result enum, we are executing the match expression, since the result enum holds two value whenever it operates over an operation. Those values are OK and error. So if it was OK, that means the file has been read successfully, and hence it must have returned some content. So that content will be stored in this as a parameter, which we can print it here. And if some error was happened during the file reading, this was be pointing via the ERR, which we can later print here to uh, see closely that what error actually occurred in that case. Or in other cases, I can create a numbers array having the strings. Uh, from them, some of are actually representing a number as a string, while others are complete string, and hence they are not a properly integer number. So on these numbers array, I'm iterating over here over each string and parsing it via the parse number function. Parse number is also returning a enum, and that expression would be as match expression here. So later, if the whatever value it returned parse number, we will check that whether it has succeeded or not. If it succeeded, we can print the number here. Otherwise, if some error has been occurred, we can check with the error E that what exact error actually occurred. So in that case, you can use the result enums for those operations which can success or may fail. In practical life, this would be very useful in the API calls, because in the real world applications, most of the time the APIs either fails or it succeeded, or if you are using it for the file operation, the use case I am already shown here. Now let's discuss the another variant of pattern matching, which are if let and while let constructs. Give me a second. If let and while let dot rs. So this is an example of if let pattern matching. Both the if let and while let uh, pattern matches are responsible for the single pattern matching. Single pattern matching means that those pattern matching scenarios where only the single pattern is to be matched, and for the other patterns it will be covered on the default cases. So whenever you are declaring a variable with a value which are actually the part of a option enum like this, let some value is equal to sum 5. So it is actually representing that 5 could be present in the memory, and this is actually be represented via the option enums. So the presence of the value in the sum variable, you can have to then check it afterwards via the match expression, where you manually handles both the sum and none patterns. So instead of this construct, you can create a shorter version, which is the iflet, to do to handle both the patterns, but in the compact way. For that, you have to specify a keyword iflet, and then you have to check the sum pattern onto the sum value, and if the value is existing, then you can print it or can can process it for something else. While for the none cases, you don't have to deal it manually. The iflet will deal with it automatically for you. Or if you actually have something to be processed in case the negative conditions arise, which we usually check it with the none enums. So in that case, you can wrap it in the else condition after the iflet. So this is how you can use the iflet. Similarly, you can use the iflet for the result enums as well. For that, uh, as an example, I am here parsing a string against the occurrence of a integer value inside that string. So for that, I am using the parse method on this string with the I32 data type, and if the parse result actually got some value successfully, then I'm checking here with the if let condition onto the OK part of the result enum, and later I'm just printing the number here which I obtained here in form of parse result. Otherwise, if after the parsing the another pattern was the error pattern, that would be handled in the else block. So this is how you can use the iflet for the both option and result enums. Similarly, you can use the while let construct as well. Give me a second. So here I have written some code for the while let. So while let construct is actually works in such a way that it actually loops over some operations as long as a value matches a particular pattern. It is particularly useful when working with the option and result enums allowing you to repeatedly extract values from the sum or OK variants from the option and result enums respectively until a none or ERR variant is encountered, which are responsible for the breaking of the loop. So its syntax is something like this, that first of all you have to provide the keyword, and followed by you have to provide the uh, one of the variant of the option enum, and later you are executing the stack.pop, and this stack.pop will execute until the sum top is actually returning some value. If it is not returning a value at any iteration, this will immediately break, and inside this you have written the println, which are responsible for printing of the stored items in the stack in each iteration. So this was the basic example of whilelet. Another example could be that where you have some set of commands stored in form of array, and then you are iterating over each of the command as well as popping them out uh, via here, and for each of the command you are then executing the if let and else blocks to actually come across with the situation that if the command is actually a valid command, then you are executing that command. Otherwise, if it is invalid, then you are just throwing an error message that the invalid command is encountered. So this is how the whilelet works in the Rust programming language. So as a best practice, you must use enums for exclusive states when a value can be belonging to multiple variants. When some of the variants in your enums is storing some data, then you have to store relevant data in your enum variants, and you must use exhaustive matching uh, to let your compiler to handle all the cases so that you do not come across with the surprising bugs, and smartly use the option and result enums for the proper error handling, and to, if some error occurs, then gracefully handle them, and combine them with the structs for complex data modeling requirements. And if you have use cases where you have to use the single pattern matching, then use the if let or the while let constructs instead of the uh, match expressions, because if let and while let helps you to perform your commands in a more compact way than that of the match expression. So there might be confusion that when you have to use the enums and in what cases you have to use structs. So use the enums when you have multiple mutually exclusive states or variants for your application requirements, and use the structs in those cases when you have related data that you have to arrange them together uh, to deal with a particular use cases. For example, if you are processing the user details for an application system, then you have to gather the related user data like username, his address, city, phone number, etc. In that case, struct will be a better choice, and enums will be fit better, or like the success and error handlings, or in those scenarios where you have multiple decision branches uh, to actually execute some commands to actually fulfill your application requirements. In that case, to actually represent the decision branch as a code in your system, then the enum will fit better than that of structs. In our next video, we will explore the Rust's collection, which holds the dynamic data structures, and those are vectors, strings, and hash maps. We will explore it through the practical coding and try to understand their performance characteristics. If you have any questions about enums or pattern matching, drop them in the comments, like and subscribe if you are enjoying and discovering Rust's powerful features. And I will see you in the next video.